Hello. Today's lesson is going to be about quadratic equation. Here is an example of a quadratic equation. This is the general form where we have ax squared plus bx plus c equals 0. Why is it called quadratic? Because the unknown appears in the index form with the exponent or index being square. Now, of course, there are other type of equations, but this is one of the specific ones, and we're going to concentrate on this in today's lesson. Now, one thing specific about quadratic equation is the formula which we use to solve it. Now, there are a couple of methods that you usually use to solve it, but this is one of them and one most common one, and one that you may be asked to do in the future whenever quadratic equation appears. Not just quadratic equation. More about it in the upcoming lesson. So the formula here states that, first of all, x is the unknown. It appears two times. It appears in the quadratic form and it appears in the linear form as just the x. Now, a, b, and c are going to be actual numbers, actual values, or variables, because they can be any number that, for example, I pick, or you can also choose, etc. And those are called the coefficients. More about them in the lesson with quadratic function when they have some properties or they give us some specifics about the function itself. Here, they're not that important. Well, in a sense they are, because they give us a formula with which we can then find the results of this equation. Now, first of all, considering the formula here given, x12 minus b plus minus square root of b squared minus 4ac over 2a, you can see that we are working with two possible results. Sometimes we're going to have two of them, sometimes there may be only one, and there are going to be situations when there are no real solutions. Now, last time, in the last lesson, we talked about complex numbers and complex set. So we may also go into that just a little bit, but we are mostly concerned with the real set and real solutions and real numbers. Now, why is this important? Well, in this formula, you can also see that we're working with a square root. It's a square root of b squared minus 4ac. Now, everything is inside of the root. Now, the values inside of it can be, once you subtract everything, can be either positive, negative, or 0. Now, depending on what's going on inside, we are going to be able to determine whether we are working with real numbers or we have to expand into the complex numbers furthermore. Okay, now let's go into the solution part. Let's go through a couple of examples and see what's going on there. Now, one thing I have to also point out, everything that I do now, you can also do using your calculator. Not any calculator, of course. You have the calculator for the Croatian State exam. You can use that, and it will give you possible solutions. Now, what I would recommend you to do is, for practice, use this formula. Not to overcomplicate things, but yet go through the method at least, so you know that one universal method for everything coming forward. And also, the calculator is just copy-paste of values. So I don't know how much you would learn from that. But you can use it. You can help yourself in the practice, so you can determine whether the answers you got are correct or not. And of course, when we are going through the assessment part, use it as a method, like a method in a sense that you make sure that you got right results. Okay. So let's go through the examples, let's go through the method, and let's see how we are going to use all of this in the quadratic equation. Let's start with example 1. And let's start with A. So example 1A is going to be equation 9x squared minus 6x plus minus 8 equals 0. Sorry, here is a minus. Minus 8 equals 0. Now, this is a quadratic equation. Why? Because the x as an unknown appears as an x squared. One more thing. Now we can also talk about the coefficients. I would encourage you to write them down, specifically because you have to then implement them into the formula. So a is going to be 9, B is going to be -6, so don't forget about the sign, it's going to be -6, and C is going to be -8, so these are the coefficients. Now these coefficients we can put into the formula, find the solution, and we are basically then finished. So let's go through the method. So let's write down x1, 2, because we want to find the solutions, x1 and x2. There might be two of them, there might not. And look at the formula. Now, I'm not going to copy paste each time the formula, but I am going to implement everything that we've written down. So B is -6. Now watch out, here is the minus before. So it's going to be minus from this, and then -6 from the number B itself. Plus minus then square root of -6 squared. Watch out, if you're squaring a number that's negative, it's also the negative sign is going to be part of the squaring. So don't forget about that. -4 times A is 9. A is 9 and C is -8. So times -8. So this is what we have in numerator. Now denominator, it's 2 times the A, 2 times 9. So we have now written down everything. Now, of course, you can use the calculator for everything from the start, but I would recommend using the calculator to determine things inside of the root, maybe finding the value of the root, and then continuing on step by step. So let's do it like this. So first of all, -6 is going to become 6. Plus minus square root of 36 is -6 squared, and minus times minus is going to give us a plus 4 times 8 4 times 9 times 8 then is going to be 288, and it is going to be over 2 times 9, which is 18. Let's continue on. x1, 2 is equal to 6 plus minus, let's sum up the things inside of the root. So it's going to be 324. I've used calculator for these things. You don't have to know it by heart, but calculating should be done in any way. Okay. Now we use the calculator to root. So square root of 324, it's going to be 6 plus minus 18 over 18. Now we have come to the most simplified version of the universal result with both plus and a minus. Now, one thing we have to do now, we have to separate now things, considering you have either plus or a minus, which will give us two possibilities. One is going to be this whole calculation with a plus, and other is going to be this whole calculation with a minus. So we are going to separate them. So let's write it down as following. x1 is going to be 6 plus 18 over 18. This is one of the results. And x2 is going to be 6 minus 18 over 18 as another result. So I have now, so to say, separated plus and a minus from the universal into the specific forms. Now, one thing you have to make sure, please do not cancel things out now. For example, you have 18 in both denominator and numerator. No, do not cancel things. It's not used to do it. You're not supposed to do it, sorry. What you should do it is actually calculate things and then subtract or whatever, or cancel things, or whatever you want to do. So let's start with 6 plus 18 and 6 minus 18. Do not ever subtract or cancel, sorry, 18 with 18 in any of these cases. So let's go with x1. 6 plus 18 is going to be 24 over 18. Now we can now simplify this fraction. So 24 and 18 are both divisible by 6. And if we divide them both by 6, what we're going to be left with is 4 and 3, or 4 over 3. So this is one of the solutions. Let's go with the next one. 6 minus 18 is going to be minus 12 over 18. Again, both minus 12 and 18 are divisible by 6. And if we divide them with 6, we're going to get minus 2 and 3. So it's going to be minus 2 over 3. And we got two solutions, 4 over 3 and minus 2 over 3. If we put any of them back into the starting equation, we're going to see that the left side is going to be equal to 0. So left side is going to become 0. Things are basically gonna cancel each other out, and left is going to be 0 and the right is going to be the 0 that we had from the start. So this is the method of solving this. This is the universal method. So what you have to do, let's go through the method one more time. Determine the coefficients a, b, and c. Put them into the formula. Calculate stuff in the formula. Simplify the first part if you have minus minus. Then calculate stuff inside of the root. Then after you get the number inside of the root, root it. You can root it. If you don't have, if you get as a result a decimal number, you can stop. You can use the root itself. But in this case, we got a natural number, so we can continue on. And once we got into this form, so to say, more simplified version of the starting formula, now we separate stuff considering a plus or a minus, so plus or minus, and then finish it off individually and get the results. So we got in the end 2 results for this task. Let's look at another example. Let's look at example 1b. Sorry, let's look at example 1b. Now in this example, the equation is going to be x squared minus 144 equals 0. Now, when you look at this here quadratic equation, it's still quadratic because x is squared, so quadratic. But unlike the example A or the general formula, we're missing something. We're missing the middle guy, aka bx. It doesn't mean it doesn't exist. It's just not visible. And this means that the coefficient with b is equal to 0. Because 0 times x is 0. So we don't have the x in all of this. The middle guy, so to say. So what we can do, we can still use this formula and try to solve it. So let's go through the formula. So let's go with what x12 for this guy. Now, first of all, you can also say, a is 1, because there is 1 times, this is 1 times x squared. You have only 1 x squared, so a is 1. B disappeared, so b should be equal to 0. This is nothing. And c is minus 144. So now we can put it all into the formula. Oh, I should have done it a little bit. I'm going to continue on like this. x12. Okay, let's go here. So minus from the formula, b is equal to 0, plus minus square root of, b is 0, so 0 squared, minus 4 times the 1, a, and times minus 144 for c, over 2 times a, which is 1. Now, a lot of things are going to disappear in all of this. So x1, first of all, minus 0 is 0, so I don't have to write it down. What I'm going to continue on is then with plus minus square root of. 0 squared is 0. Minus and a minus are going to become a plus. 4 times 144 is going to give us 576, I believe. And this is going to be over 2. Now, following step is to see what's going on with the root, if we can root it. So plus minus root 5 of 576 is going to be a natural number. This is good. So it's going to be 24. 24 over 2. So we have now plus and a minus 24 over 2. Let's divide now for the individual results. So x1 is equal to 24 over 2, and x2 is going to be the minus 24 over 2. Now, of course, we can solve both of them. 24 divided by 2 is going to be 12. Minus 24 over 2 is going to be minus 12. And we got 2 solutions, 12 and minus 12. Now, this is using the universal method. Now, let me go back to the original equation. X squared minus 144 equals 0. There is another method you can use, and it's simpler, I would say. What I would do now is put knowns on one side, unknowns on the other side. So how I'm going to do that? I'm going to add 144 to both sides. So x squared is going to be equal to 144. And now the following logical step would be, I want to get rid of the square. How am I going to get rid of the square? I'm going to root. Now watch out when we root. When we root things, I'm not going to go into the complication stuff and everything. What you just have to remember that the solution of all of this can be both a positive and a negative number. Basically, what you ask yourself is the following. What is the number that when it's squared gives us 144? One of them is going to be definitely 12, but another one can also be minus 12, because minus 12, when you square it, the minus is going to disappear, and 12 squared is still 144. So these are the two solutions. Now I've written it differently a little bit. Instead of using x1 and x2, now I have just x is either 12 or minus 12. And this is another method of solving it. I wouldn't say this is the common, I would still recommend to say x1 is 12, x2 is minus 12 as the ending solution to make it mathematically correct. And this is another method you can solve with which you can solve the given equation. Now, this is only for the equation that's given here, this type of the equation. Meanwhile, the general method works for both of these, no issues and no problems. Now I'm going to go with the third one, the third example, and go with a 3x squared plus 27x equals 0. Now what we're missing in this here equation is the coefficient c. It doesn't mean it doesn't exist, it just means it is equal to 0. So a is in this case 3, b is 27, and c is equal to 0. Now you can go, and I would recommend you to, for practice, try it yourself using the universal method, so meaning using the formula for the results. Try to solve it that way, and you're going to find the solutions. Now, I'm going to show you another method, and then you can check if everything worked fine. And this method is going to be like this. I'm looking at what is common on the left side of this equation. On the left side we have 3, but 3 doesn't only appear in x squared. 3 also appears in 27, because 3 is basically 27 is basically 3 times 9. So we have 3 in both of them, meaning we can extract the 3. Not only can we extract the 3, also x appears in both of these parts, both in x squared and x. So we can extract the 3 and the x from both of these parts. Now, what happens is the following. We have extracted 3x. What is left? We have to ask ourselves. So from 3x squared, only thing that is left is x. So if I multiply 3x with x, I'm going to get 3x squared. Good. Now from 27x, what we are left with is, okay, x is already outside, so there is no more x's. So first of all, plus, I copy-paste the sign. And instead of 27, I'm now left with 9. So x plus 9, meaning if I multiply 3x with x, I get 3x squared. If I multiply 3x with 9, we're going to get 27x plus 27x. On the right side is equal to 0. Now this here method is called factorization. Why is it factorization? Because we got factors. At the beginning, we had a sum. Sum of parts gives us zeros, or sum of the elements gives us the 0, while now we have 3 factors that multiplied give us 0. This is simplification in a sense, because now we can determine what of these parts can actually be equal to 0. Now watch out. If you have two values, a times b equals to 0, value a and b equal to 0. If they are part of the product, or their product is equal to 0, this means that one of them has to be equal to 0, because 0 times 9 equals 0, 0 times 20 equals 0. 100 times 0 gives us 0, etc., etc. So it's either that a is equal to 0 or b is equal to 0. One of them has to be 0. So if either one of them is 0, then the whole product is going to be equal to 0. Now from the equation here, 3 is a number. It's different from 0. And yeah, it's not going to give us the 0, which gives us only 2 possible candidates for the 0 itself. It's either going to be the x, so x is equal to 0, or x plus 9 equals to 0. So we have two possibilities. X is equal to 0. This is perfectly fine. Why not? And this is going to be the first solution. We can also mark it down. Meanwhile, for x plus 9, we have to still solve it. So I'm going to subtract with 9 both sides. So x is equal to minus 9. And this is going to be the second solution. Now, if you went through the universal method, like in the tasks or examples 1a and b, you would get the same results in the end, and you should get the same results. Now, considering the methods, these are the three methods that I've shown you now. You can pick whichever you like. Universal is the one that you can always use for whatever quadratic equation you're given. You can always use it. The main idea for the universal method is that you can determine the coefficients and then use the coefficients to put them into the formula and solve using the formula the equation. Now, so far, when we looked at all these tasks, all three examples, we got three solutions in both of, two solutions in each of them, and this is okay. Now, I've told you that there are going to be situations where we are going to get only one solution. Now, let me show you with one more example. I'm going to use a simple example for that. You can use the calculator to make sure that I've done things properly. You can check me in a sense. So the example is going to be x squared minus 6x plus 9 equals 0. Okay, this is going to be the thing that we're going to go with. Now, if you use the calculator, you are going to see that you're going to get only one solution. And let's go with the universal method to solve it. So this means a is equal to 1, b is equal to minus 6, and c is equal to 9. Let's go with the solving. So minus 6 for the b, plus minus square root of minus 6 squared, minus 4 times the 1 for a, and the c is 9, okay, times 9, over 2 times the 1. Let's start solving this. So minus 6 is going to give us 6 plus minus square root of 36 minus 36, because we have minus 4 times 1 times 9, which is going to give us 36, over 2. Now, what happens now is inside of the root, 36 minus 36 gives us 0. So square root of 0 is going to be equal to 0. So what we get is that 6 plus minus 0 is equal over 2 is the end result. Why is it in the end result? Because if we add 0 to 6 over 2, nothing changes compared to if we subtract with 0. So basically what we have is 6 over 2, or number 3. So it doesn't matter whether you add or subtract with 0, the ending solution doesn't change, and we get just one number, and this is 3. So this is an example of one solution. Now, what can give us the idea of number of solutions? This is another thing that you may be asked, and this is going to be now the follow-up to the quadratic equation and the following lesson. Now, I'm going to do it all in one video. This is now a follow-up. Now, what this means is, and when you look at the formula, let's look at the formula. This here part is important part to what we're doing. So plus minus square root of b squared minus 4ac is going to determine the number of solutions, the number of real solutions, basically. Because you have a plus and a minus. Plus and a minus already imply that we have two possibilities, like we had in a and b, or c then following that, but universal method idea. So we had to divide plus and a minus into two situations, one with a plus, other with a minus. Same here, plus and a minus, plus and a minus. Or here was a plus, here was a minus. So this is one thing concerning the idea. Now there is another thing concerning this idea. Now what happened in these let's say A task and the D task? is that inside of the root, things have worked a little bit differently in a sense, or we got different situations. In task A, we got a positive number inside of the root, which is good, and we got two solutions. Look at this in B example. We also had two solutions in the end, starting with the square root of a positive number. In D example, we had a situation with a square root of 0. So this was a square root of 0. We had this situation, and this gave us in the end one solution. Now, what would happen if we got, and this is possible because you have subtraction. Look at this. If here was just a plus, for example, here was a plus, you would have here minus 288. So if you had 3 to 6 minus 288, you would get the square root of a negative number. And this is where we get into the complex set and the complex numbers. Now, I'm not going to delve into them that much. I don't think they are necessary that much for you. What is necessary is to determine the number of real solutions. So there is a term with a quadratic equation that determines the number of solutions. And I've basically now talked about it. Now I'm going to just define it. And the term is going to be called discriminant. The term is called discriminant, big letter D. And the formula of D is basically what is going on in the root. So inside of the root, not the root itself, inside of the root. So b squared minus 4ac. b squared minus 4ac. So this is the formula of the discriminant. And if the discriminant is, let's now write this down, if the discriminant, the solution that we get, the number that we get, is greater than 0, like in example A and B, then we got two real solutions. Like in the example D, this discriminant was equal to 0. This was the inside of the root. It was equal to 0. And we in the end got one real solution. Now, I haven't given you the example of the negative discriminant or negative value inside of the root. So I'm just going to mention it now here. D is less than 0. This will lead us to 0 real solutions. Or in the complex set, 2 complex solutions. 2 complex solutions. But I'm not going to ask that. Let's concentrate on the real set. Let's concentrate on things that are real for us and the basics of it all. Now, the tasks that work or that use the discriminant method is the task where you basically got the question, how many solutions does an equation have? Now, of course, now you can logically think, well, I can use a calculator and put everything in the calculator, or use the method like before to determine everything, find the solutions themselves, and then just see if there are 2 of them, there is 1 of them, or there are no real solutions. Of course, you can do that. But the idea here is, or general in mathematics, is to use the simplest way, fastest way possible to determine the solution. So let's go with an example where we're just going to do that, and I would personally ask you to do this as I'm showing you here. So let's go with the example 2 and A. So the equation now is 3x squared minus 5x plus 4 equals to 0. And I just want to determine the number of solutions. Just the number of solutions. I don't care what the solutions are. So what we are going to do, we're going to go straight into the discriminant and use the discriminant. So what we get as a result for the discriminant is going to tell us whether we have 1, 0 or no real, 1, no or 2 real solutions. So the formula is b squared minus 4ac. Now, I'm not going to write down every time what is a, what is b, what is c. I think you should already know how to do that. I would encourage you to do that if you're not 100% sure. So b is minus 5. So minus 5 squared, minus 4 times a is 3, and C is 4. Okay, so D is equal to 25 minus 4 times 4 times 3 is 48. If you subtract 25 with 48, we're going to get minus 23, and we got a negative value for the discriminant. So this would mean that inside of the root is a negative number, which gives us the answer that, first of all, D is less than 0, meaning there are 0 real solutions. Let's look at example B. In the B one, 4x squared plus 4x plus 1 is equal to 0. So this is another example. Let's determine the number of solutions. D is equal to 4 squared minus 4 times the 4 from A times 1. Okay. D is equal to 4 squared is 16, minus 4 times 1 is again 16. 16 minus 16 is equal to 0. And now we can determine that we have D is equal to 0, discriminant is equal to 0, meaning there is going to be one real solution. And let's go with third example, example C, with one more equation, x squared minus 10x minus 3 equals to 0. Same idea, I want to find the number of solutions, number of real solutions. So the discriminant is going to be minus 10 squared, which is b squared, minus 4 times the a is 1, times c, which is minus 3. Watch out, there is a lot of work with the minuses in all of this. So minus 10 squared is altogether 100. If you're using the calculator to find the square of a number, negative number specifically, you have to copy paste the bracket and inside of it the minus. So we'll make sure everything works properly. Minus and a minus are going to give us a plus. 4 times 1 times 3 is altogether plus 12. So discriminant is 112, which gives us the answer that discriminant is greater than 0. 112 is a positive number, and this means 2 real solutions. There we go. And this is a talk about the discriminant. So if you're asked how many solutions does a quadratic equation have, you can just use this. Now, I would personally say this is if you're using if you're calculating everything, I would say that calculating this is much quicker or simpler than going through the whole method and determining the solutions themselves. So this is why the discriminant is good. Now there is one more thing you may be asked, one more set of formulas that you concerning the quadratic equation that you have been asked, using the same starting formula or equation. And this is going to be Vieta's formulas. Vieta's formulas. Now, these formulas are specific and they tell us a couple of things about the solutions. They don't tell us what the solutions are, they tell us how they live together, so to say, or how we can get something specific. Now, first is the sum of solutions, so x1 plus x2. Now, Vieta found out that the sum of the solutions of the quadratic equation is equal to b minus b over a. So, coefficients can determine the sum of solutions. Same thing is for the product of the solutions. So x1 times x2, the product of solutions Vieta found out is always going to be equal to c over a. Now these formulas, none of them you have to know by heart. They are given in the state exam, they are given in the general formula, so you can always use it. For example, this is generally not given. This is the formula you generally do not know, but since you are usually given the formula or universal formula for solving quadratic equation, the discriminant appears inside, so you have it already in a sense, even though it's not precisely given. Now, when is this used? It's just fun. This is just for fun. Mathematicians, you wanna have fun too. They're not just all about numbers. So what you can be, what is the type of the task that you may be asked of? Well, simple as that. Determine the sum, determine the product of results of quadratic equation. In the meantime, important step is, if you're asked something like that, I don't want you to determine the solutions themselves. The solutions themselves might be complicated, really complicated numbers. So instead of going ham on them, going through the beginning with all of this, no, go simple enough, use these formulas to determine, well, you have coefficients, you just put in the coefficients of the equation and you're going to be done. Let's see how it works in example 3. So we want to find the sum and the product of quadratic equation solutions. A, 2x squared minus 3x plus 1 equals to 0. Let's go with that. Let's start with the sum of solutions. So x1 plus x2 is equal to. Now I have to use the formula that it is equal to minus b over 2. So this is one of the Vieta's formulas. Okay, so minus b over 2, this means minus is in front for this, then minus 3 for b, and over 2. Minus and minus are going to cancel each other out, and we are left with 3 over 2. So sum of the results of this here equation is 3 over 2. Have I found the solutions themselves? No. Do I care about them? No. Let's go with product. So x1 times x2. Let's see what we're going to get for the product. So this says it is c over a, meaning it's going to be 1 over 2. Done. Let's look at another example. And this is going to be the last example for today's lesson. So example B. And this here equation is going to be 2x squared plus 10x minus 10 equals 0. Let's start with the product. Let's start with the sum. Same idea as before. So x1 plus x2. We need to determine, okay, minus is going to be in front of the formula here. Okay, b is 10 because it's a plus 10 and over a, which is 2. Minus 10 over 2 is going to be minus 5. We got the sum. Sum can be a negative number. Why not? Let's find the product. So x1 times x2. Similar situation. Now, c is minus 10. So this is minus from the c. And over 2 for the a. Minus 10 over 2 is minus 5. There we go. Now, what happened here is that we both got from the sum and the product the same answer. It doesn't have to be like that, okay? So you don't have to fuss yourself about that. It always has to be like that. No, it just is. It just happened in this here situation. Don't worry about it. It can be anything. They don't have to have anything in common with one another. But the idea is we found the sum. We found the product for each of these equations. And this is today's lesson. See ya.